Dear Foundation Society, welcome to the future. Our design for the new Mark IV Carolina is able to carry 300,000 kilos of cargo, spread across 73 casks. Alternatively, in passenger mode, we can fully accommodate 300 passengers. The Mark IV Carolina carries 9 SAT-F4 engines, providing a maximum mass of 558,000 kilograms. The walls of our Carolina consist of 3 layers, 2 sheets of aluminium with a thick aerogel layer between them. Our ship also conforms to the medium-sized class specifications, with 2 main airlock hatches placed in the allowed areas. Given the engine specifications, our rocket will spend 10 minutes accelerating up to a maximum speed of 10 km per second, given by the Tucholsky rocket equation. During this time, if passengers are on the flight, they will have to stay seated in specialized seating areas. After this acceleration, our vehicle will continue by coasting, with passengers now free to roam as they please in 0G. Our ship makes use of a cask airlock on its front, where casks can be loaded on and off the ship when it is docked. We've also built a multi-axis conveyor belt system into each of the 4 floors inside. This, combined with an internal cask lift, allows for 73 casks to be autonomously distributed. After being loaded, they're locked in place by our cask curing system. Then, our HUMMINGBIRD-M robots connect them to the ship's power grid and, if necessary, the water supply. We've designed a number of custom casks, residential casks, leisure casks, medical casks, and more. These boxes conform to cask dimensions but contain rooms inside. This means that after a cargo run, all cargo casks can be unloaded autonomously and custom casks for the passengers can be loaded onto the ship. Just like that, a cargo ship transforms into a luxury passenger carrier. During the acceleration stage, our engines will be set to thrust mode, where their total power production is 18 kilowatts. Only critical life systems will be powered during this time, such as heating and light. After the ship starts coasting and the engines are switched to power mode, power is allowed to the amenities on board the ship. We also store some power on board in the case of emergencies. When being used completely as a cargo ship, 55% of the ship's mass is dedicated to cargo, and when being used as a passenger ship, 27% is used for passengers. Since any configuration of cask can be loaded, the ship can quickly be adapted to meet changes in demand. Here are a few sample floor plans and renderings of the different casks we have designed for our passengers. These will be placed specifically around the ship so that everything is accessible for everyone. As you can see, there's plenty of space per person aboard our ship. In order to keep things running smoothly inside the ship, we've designed a few different robots. Here are our designs for cleaning and maintenance robots, which improve overall self-sufficiency. Here are helpful guide robots which can keep people company, answer their questions, and give them directions or flight updates. All of these robots will have onboard batteries and will navigate to a designated charging cask when they're running low on power. A few other small features we've included to increase operational efficiency. A water recycling system so that all grey water is purified and reused. This is particularly useful as it means we don't need to carry as much water. The aerogel layer between 2 aluminium sheets is not only useful for stopping space projectiles, it also functions as amazing insulation, reducing the energy spent on heating. Finally, we've included small tuning boosters on the craft to allow for easy turning and deceleration. Finally, we have made sure to be prepared for the worst case scenarios. Each of the 4 floors in our ship is separately pressurized, only connected by airlock-like elevators. This means that in the event of hull rupture, despite the protection of the composite walls, only one floor would be compromised. Additionally, large pockets of sealant have been placed periodically throughout the whole of our ship. In the event of a rupture, these bags of sealant would burst, covering the rupture and temporarily sealing the hole. The passengers on this floor would be evacuated to upper floors by our guide robots and crew, and temporarily housed there until the rupture is safely sealed by our maintenance robots. Throughout the flight, our ship would be monitoring the status of solar flares. In the unlikely event that information is received of a flare that's headed towards the ship, the following measures would be taken. All passengers would be immediately evacuated to a center cask with extreme radiation shielding, thick lead walls. All 300 occupants would be able to fit in a single cask. This is actually possible despite being crowded. The ship would turn to face the direction of the flare, minimizing its profile. Finally, all non-critical electric systems would be switched off to minimize electrical damage. Our ship will cost a total of $1.4 billion, but with the supreme efficiency and safety we provide, we hope you'll choose our design for the next Mark IV Carolina. Thank you.